Hello, am I audible?
I can hear you.
Okay, Jay? Hema, we cannot hear you.
Hello, are you there? Are you able to hear me? This is Jay here.
Yeah, hi Jay, I'm able to hear you.
Hello.
Yeah, hello Jay, you're audible. We can hear.
Okay, thank you.
Jay, can you just give a quick introduction about yourself? That
Yeah,
please go ahead.
just a minute. Yeah, hi, I'm Jay Ganesh. I'm an IT professional. I have 10 plus years of experience in mainframe.
Okay.
I want to switch over my technology from mainframes to Java. So that is the main contention, I mean intention of this course.
Alright. Okay, that's good. So, Sarfaraz?
Hi, this is Sarfraz. I'm here based in Seattle. I'm also into IT, been working for about 14 years now, mostly as a business system analyst. Um, Currently, I'm managing a group of senior developers, and our project is heading into Java technology. So I wanted to brush up my skills on Java. Been many years I've coded in Java. So I'm here.
Okay, thank you. That's good to hear. Hema, can you please speak up if in case your
Yes.
mic is on? Your mic is, please unmute your mic and then you can speak.
Hi, can you hear me?
Yeah, now we can hear you.
Yeah. Hi, this is Hema. I am an IT graduate. I'm looking for training in Java since I'm planning to work on EAD right now. I worked in India for 1 year as a Java developer. That's long back, so I want to brush my skills before going ahead.
Okay, sure. So let us now start with Java. Now in this session what we will be covering is the Java history, features of Java, Java versions and where Java is applied. Now first starting with the history of the Java, this was started as a Project Green by James Gosling, Mike Sheridan and Patrick Norton. And this was started somewhere in the year 1999 at Sun Microsystems. Now initially Java, like as of now, as of today, you find the Java everywhere, like from the small-end devices to the high-end servers. But initially when the project was designed, it was not designed for the Java to work on for the high-end systems. It was basically designed to write a software system that will work for small electronic devices. And initially this project, it was called as Green Talk. And now these days, okay, whenever you're writing a Java program, you find the extension as .java. But prior to that, initially when it was in the development state, it was .gn, .green, because the project was named as Green Talk. And prior to naming, first the name of the Java was Oak, but there already exists a language by name Oak. So that is the reason after many conferences and all, okay, they have given the name as, they have given the name to the language as Java, and you will find the various stories on this. Why did they give the name as Java to the language? You can Google that on the internet. And originally this Java was developed, it's Sun Microsystems by James Gosling, but later it was acquired by the Oracle. Now Oracle as of now is maintaining Java, and this is the picture of the person who has written the JVM. This is James Gosling. Now this was a brief history of Java. Now let us move towards the features of Java. One of the features of the Java is that it is simple. The reason Java is called as simple is because you will find the construct similar to that of the C++. And as per the statistics, what they have found is the most of the bugs in the programs are because of the pointers. So they have eliminated the use of pointers itself. So buffer overflow, buffer underflow, all these errors were there because of the use of pointers. So in order to make the language safe, they have eliminated the use of pointers. And then we have operator overloading and multiple inheritance. Operator overloading and multiple inheritance, it is the feature of object-oriented programming language. That is, if you are familiar, C++ implement both of these features, operator overloading and multi-threading. Sorry, operator overloading and multiple inheritance. But in Java, they again prohibit the use of multiple inheritance and operator overloading because of various pros and cons. Go-to statement is eliminated. We don't have go-to statement because if you are using the go-to statement, we don't have any structured order. The problem what happens with the go-to statement is you can jump from line number 1 to line number 2. From line number 2 you can jump to line number 10. That is, there is no order in branching. Straight away you can jump from one location to the another location, and at the end the code will become too much messy to understand the flow of control. So that is the reason go-to statement is eliminated. We don't have header files. Instead of that, okay, we have got packages. And then the most important feature what we have is like garbage collection mechanism. And the garbage collection mechanism, what we have is the data, or like when you allocate the memory as well as you deallocate the memory in C++ programming, or in C, calc and the malloc we have. You allocate the memory with the help of new operator, and then we deallocate the memory with the help of delete operator. But in the Java, we have got a garbage collection mechanism that will take care of freeing up the memory. So are we clear on this, why Java is simple?
Yes.
Yes.
Okay, fine. So now let us proceed. Now, features of Java, the another feature of the Java what we have is it is object oriented. Now in C++ you can write the programs in both the styles. That is, we can write it in the C style as well as in this object oriented style. So C++ we say it supports both the styles, that is function oriented as well as object oriented, whereas Java it supports only object oriented programming. That is, from the beginning itself, it forces the programmer to make use of the object oriented style, object oriented paradigm to develop the programs. Now, in functional programming, your code mainly revolves around functions. In functional programming, the code mainly it revolves around the functions, but in the object-oriented programming, all your code will revolve around objects. In the object-oriented programming, all the complete code will revolve around objects. So, if you have to implement any functionality, you require an object. You can say it revolves around classes. Down the line, we will be discussing what is an object and what are its properties, how it is different, how it stands different from the function programming. But as of now, I will just discuss that in the object-oriented programming, you have got your code will revolve all around objects. Your objects will have something called state and then the behavior. If you consider the example, let's consider contact as an object. If you consider your mobile operating system, there the contact what you're creating, it is an object. The contact what we are creating, it is an object. So object, it has got state and the behavior. State is represented by the fields of the object, that is the properties what you have. So you have name, you have got number and all, okay, that comes under state. And what you can do, you can call, you can message, all this will come under operations. So in the object-oriented programming, so we concentrate on two things. One is the data and the other thing is the operations that can be performed on the data. So if you consider contact as an object, so over here what you have is let me take help of one word. So if you speak on object-oriented programming language, let's say again this is your object. It has got two things. One is now over here you may have the fields. This is your data. Name you may have, number you may have, email, etc., etc. So this is what, okay, you have the data and okay, you can make various operations on this. So operations, what we can do is on your contacts, so you can call, okay, you can call, you can send a message, etc., etc., etc. Clear with this? So the operations, what are you doing? You can give a call. You can give a call onto this number. So this is how it works. Are we clear on this?
Yes.
Okay, fine. Thank you. So in object-oriented programming, okay, if you see over here, you have got data, and then okay, you have got the operations that can be that can be performed on the data. So over here, the data is center is the key point in the object-oriented programming, and you have to write functions wherein okay, you will perform the operations on the data, whatever we have. So your data will differ, data as well as function will differ from object to object. Then okay, another feature of the Java is robust. If you see over here, memory. If you see over here, memory allocation concept, okay, we have got garbage collection concept. That is, if you are allocating memory, you don't have to deallocate the memory. You don't have to write the code to clean up the memory. It is the garbage collection mechanism that is responsible for cleaning up the memory. Is this clear? And then you have got exception handling mechanism. In the exception handling mechanism, what we have is when you are executing the program will execute successfully from start to the end. That is, your program will not meet across any field or will not fail at any point of time. But if in case if your program failed, then there should be a way to recover from that. Then there should be a way to recover from that failure or give an appropriate message to the user. Let's say you are unable to connect to the internet. You have written a Java program that connects to the internet. So your code is fine, but there are points because there are at times it is possible that you are not able to connect to the internet because the server might be down. In that case, rather than just crashing the system, what we receive is, okay, you should receive some error message saying, please check your internet connection. I repeat, let's assume you have written a Java program that is responsible for connecting to the internet. If the server is up and everything goes fine, your Java application is connected to the internet. This is called a successful execution. But let's say you're trying to connect to the internet, but the server is down. In that case, your application is not able to connect to the internet. In that case, okay, your application should not crash. Rather, it should give you the message that please check your internet connection. So that is what, okay, Java provides. There are many mechanisms have been provided by the Java to recover from the failures. Are we clear on this?
Yes.
This one, object-oriented exception handling of runtime methods. And then extensive compile time and the runtime checking we have. And then type safety of the data. Type safety of the data, it is implemented in all the programming languages. That is, if you say that you will store an integer in a memory location, Java will let you store only integer value. I repeat, type safety is, let's say in the very basic terms, if you say that if you have allocated a memory for storing the integer data type, then Java will let you store only integer data type. If you're trying to store some other variable, let's say if you're trying to store some characters in the integers, then the Java will not let you, even though it can store, because memory is sufficient to store, but the data type does not matches. So that is what we call it as type safety of the Java, and this one is the feature. So these are all the features that makes the language robust. And any questions on this? Are we clear with the feature of the Java? Any questions on this?
Yes.
Can we proceed? Okay, the next what we have is the next feature what we have is architectural neutral and interpreted. Now whenever we have the languages, there are two types, either compiled or interpreted. So can anyone let me know what you mean by compile and what you we mean by interpreted? What is compile and what is interpreted? What is compiled language and what is interpreted? Anyone? Anyone from the participants, can you please volunteer this question? Any idea on the compiled languages? Yeah, please, Sarfraz.
So the compile case, what happens is the code is basically checked for all the syntaxes
Yes.
the right code before it's even executed.
Yes.
But interpreted is when it's actually running at the same time. So let's say
Correct. Compilers.
in
Yeah, please.
both the activities at the same time.
Yes, correct. So in the compile language, as said by Sarfraz, what we have is your complete code is translated into the object code, complete code. If you have written 10 lines of code, all the 10 lines of code is translated into the object code, into the machine code in the compiled languages, whereas in the interpreted, the code is translated as well as executed line by line. The code is translated and executed line by line. That is what we mean by interpreted. So Java is both, it is compiled as well as interpreted. Java is both, it is compiled as well as it is interpreted. Now let us have a look on this. Java is architectural neutral and then interpreted. So you write the Java code, and your Java code, that is the source code, is saved with the .java extension. Then this code is submitted to the compiler. This code is submitted to the compiler. Once this code is submitted to the compiler will compile the code and it will check if there are any errors. If there are any errors, then the errors will be listed out And if there are no errors, it will generate a .class file over here. It generates a .class file. So this .class file that is generated, this is system independent file. If you observe, you have compiled the code only once and you are capable of running the code on Solaris, on Linux, on the Windows, provided JRE is enabled, provided you have JRE on that machines. So that is the reason we say Java is architectural neutral. That is, the code whatever you have written, you're not writing specific to the machine specific architecture. The code we are writing is not dependent on the machine architecture. So till here, see over here, now this is your .class file that is generated. So this .class file, this is machine independent. Now, then what happens is, then you submit the code to the interpreter. Then the code is submitted to the interpreter. Now, this is your interpreter. This is your interpreter. So the job of the interpreter is to translate the code from machine independent to machine dependent. Clear with this? Now interpreter will take the responsibility of translating the code from machine independent to machine dependent based on the machine architecture. Are we clear on this? So Java is both, it is compiled as well as interpreted. Clear with this?
Just a quick one. So the interpreter files will have different extensions, or it will be the same?
No. Like the command what you give is only Java. Java and then the class name. Let's say okay, you're having a class called custom. You'll not give any extension. That's it. So Java is your interpreter. So Java is what? It is both compiled as well as interpreted. So that is what it makes the language architectural neutral. So up to here it is machine independent. Up to here the Java bytecode that is being generated, it is machine independent. Then it translates this machine independent code to the machine dependent code with the help of the interpreter.
So that will be as a part of the compilation process itself, right?
Can you please repeat your question?
That interpretation part will be once we compile, it will be like compiled and interpreted, or one we have to do separate process like for interpretation.
Now compile and then okay, you don't have to interpret, okay, you just give the command, okay, the process is automatic. We don't like as we are compiling, like we are executing the command to compile, but okay, you don't have to execute you have to don't give a separate command to interpret the code. What we are having is okay, this is the utility that is provided Java to execute the program, and the JVM will do the process automatically. You just have to give the command Java customer, and you will find a lot more of internal structure, internal details that is responsible for interpreting your code. We don't have to give a separate command to interpret. So you give this, okay, it will load the class, it will compile it, bring all the classes whatever are required into the system, and then it will submit the code to the just-in-time compiler where it starts converting it to the, where it submits the codes to the interpreter, wherein it starts converting it to the machine code. And as well as okay, it starts executing it. So for that, okay, this is the high level structure. If you are more interested, okay, then we can discuss JVM internal structure, where you will learn how internally it works. But as of now, it is not required. Clear with this?
Okay, yeah.
So as of now, what we have to understand is you have to compile the code. Once the code is compiled, then you have to execute it. And the execution of the Java is done in two different steps. And up to here, you can say this is compilation. Let me just pick up, sorry. And up to here, this one, this is compile. Till here it is compile. And this section is interpreted. So Java is both compile as well as interpreted. So when it is compiling, what it is doing is it is generating the machine independent code. The output of the compilation is this byte class file, and this bytecode that is generated is machine independent. So machine independent in the sense it is not dependent on architecture. As you can observe from this diagram, you can pick up the bytecode and you can run on any operating system that has the JRE, Java Runtime Environment. If the Java Runtime Environment is there, you can execute it. And in order to execute, you require interpreter. So that is the reason we say Java is both compile as well as interpreted. And then Java slogan is write once and run anyway. If you observe over here, you have compiled or you have written the program only once, and the program is capable of running on all the operating systems. Clear with this?
Yeah.
Now, Java is powerful. The reason Java is powerful is because of the features it has, because of the features that are provided by the language. Java has got support for networking. That is okay. You can write all network related applications using Java, and it has got built-in support for threading. Threading is you can perform multiple tasks within an application. And one of the again most important feature of the Java is distributed objects, distributed programming. We'll be discussing this. What do we mean by distributed access? Database access. You can connect to the databases from your Java program, and it supports 2D as well as 3D graphics library. It has got built-in data structure library, and then it supports serialization as well as digital signatures. Java by default is popular. It is the most popularly, very much popular. It is the language that is used most popularly, and you have got like many advances that are being done in the Java Spring framework, Hibernate. Like Spring is upgrading very quickly as well as you find the changes in the Hibernate. So that is the reason Java is becoming very much popular in the market. Now, let us understand this distributed concept. So what do you mean by distributed systems? What idea you have about the distributed systems? Hello? Any idea on distributed system? Now simple, let me say, tell you. Distributed application means you write the program once and it should be capable of running your application on the systems that are running all together, different hardware as well as software. Now internet became popular in 1995, and the Java also became popular in 1995. Now when the demand for the internet was growing, so the requirement or the need was, when the demand for the internet was growing, the need was, that is, if you are writing an application, this application should run on the various client machines. You expect the same application that you are posting on the internet to run on the different client machines. So these different client machines, okay, may be running on the different hardware and the software all together. So the requirement, also the need was that is your program should be written in such a way that it should be distributed across the internet. That is, if anyone is accessing your program online, then that program should execute on their machines irrespective of the hardware and then the software whatever they are running. So the answer to this was Java, because as we have discussed, Java is architectural neutral. Java is architectural neutral. That is, you just write the program once, and once the program is posted on the internet, then it can be accessed by any client machines irrespective of the hardware and as well as the software. That is what we have, the distributed nature of Java. And then the core concept what we have is, let's say you have got server 1 over here, and then okay, you have got server 2. You have got server 1 and then you have got server 2. Now let's say okay, on the server, on this JVM you have some code running, and this is the another JVM. Total, okay, you have got two different set of JVM. So this is one JVM, sorry, this is one server and this is the another server. So these two objects, they are running on altogether different JVMs. Now because of the distributed nature of Java, what we have is this object, it can invoke the services of this object. Generally what happens is, the objects are running in the same JVM, so you are calling the objects locally. You are calling the objects locally. So what do we mean by locally is, so you have got two objects that are running on the same system, and object 1 is calling object 2 on the same machine. That is called as local execution. So you're calling the objects locally. Now the remote execution means, okay, you have the JVM that is installed on one server or running on one server, and then okay, we have the JVM that is all together on the different server. But still, objects from one JVM, they can interact with the objects that are running on the another machine. So this is called as distributed programming. So this is altogether different. Clear with this? Is it clear?
So all the machines should be having this JD, JRE.
Yes, all the machines they should have JRE, correct. So are we clear on the distributed nature of Java?
Yes.
Okay. Okay, let me not discuss this. Now, next what we have is Java. Java has got built-in support for multi-threading. So when we say built-in support for multi-threading, it means now over here, if you start the task manager, that is within the operating system, we have these many processes. Okay, total we have got 109 processes that are running. Total we have got 109. At the OS level, if you have more than one application that is running, then you call it as multitasking. We call it as multitasking. But within an application, if you have multiple operations that are executing in parallel, then we call it as multi-threading. I repeat, at the OS level, if you have more than one process that is running, then you can say it is multiprocessing or multitasking. It is multitasking at the OS level. But within an application, at the application level, it is called as multi-threading. At the application level, it is called as multi-threading. So multi-threading is introduced because these days we are getting the CPUs that are of high, that has got huge processing power. So to utilize the CPU to the maximum extent possible, the concept of multi-threading is introduced. So multi-threading, it will support parallel processing. Multi-threading, it supports parallel processing. Let's say okay, you've got the WinWord application that saves the document for every 10 minutes. By default, what we have is in WinWord, it will save the document for every 10 minutes. So file and then options without the user intervention, somewhere I think here. So for every 10 minutes, okay, it will save auto recover information every 10 minutes without the user intervention. So what we have over here is we have got a thread that is executing in the background that will save your contents to this location. That will save the contents to this location for every 10 minutes. That is over here. Now, or else let us take an example. So this is one of the multi-threading. Now let's say okay, now we are typing. Now as you are typing, it is checking the spellings. As we are typing, we have one more application or we have one more operation that is responsible for spell checking. So over here we are performing two tasks within the Word application as of now. You can see we are typing the text as well as it is performing spell check. So within the application, if you have more than one task that is running, then that is called as multi-threading. So the major Java editions what we have is standard edition, you have enterprise edition and the micro edition. Java it comes in 3 edition: standard edition, enterprise edition and the micro edition. So your standard edition is used for creating desktop applications. If you want to create any desktop applications, wherein okay, you want the application to be available on the system itself, then you go for the standard edition. Then we have got enterprise edition. It is used for creating the server-side applications. And then finally we have got micro edition that is used for writing the programs in the Java for the devices, for the handheld devices or for the small devices that has got limited processing power. So for the standard edition it is JSE, for enterprise edition it is JEE, and for micro edition it is JME. So standard applications, it is used for desktop programming. Applets you have, like these days we don't use applets. JavaFX. This JavaFX, it is used for creating the graphics. And big data apps, they use Java in order to write the programs. Minecraft, Eclipse, NetBeans, etc., etc. These are all the standard Java desktop applications that have been developed using Java. Now next, enterprise edition. Earlier it was called as J2SE or J2EE. Now we don't have this 2, they have removed this 2, it is JEE. Java EE stands for Java Enterprise Edition. So the core technologies what you have is servlets, JSP, and then EJB. These are maintained and developed by the Sun, and whereas JSF prime phases, these are the front-end technologies. Spring and the Hibernate, they are server-side technologies, distributed technologies you can say. And the examples what we have is Amazon.com, eBay, PayPal, etc., etc. All these sites they are built using Java Enterprise Edition. Micro Edition, Java that run on the small devices, cell phones.
What is that prime phases?
Prime phases, it
Sorry to interrupt. What is it?
For developing front end. JSF,
Okay.
prime phases, okay, this is the technology for developing front end. So JME you have for writing the code and for mobile devices and all. So in JSC you have got JVM, whereas for JME you have got a different virtual machine. It is KVM, kilobyte virtual machine. The reason we have kilobyte virtual machine is because you are running the Java programs on the small devices. So obviously the JVM, you cannot make use of the same JVM because we have got limited processing power, and because of that the JVM has been redesigned and it is called as KVM, kilobyte virtual machine.
And one more thing about the big data apps, you mentioning something, right? Can you please repeat that?
Yes. So over here, big data apps, that is okay, when you are working on big data, if you have to write some program and all, so in that, okay, you have to write the code in Java in order to write some, if you want to add some functionality to the data that is being processed.
Okay.
So if you want to gain, like anyway interface is provided, but if you want to process data and all, in that case you have to write the code in Java. Now these are the various releases of Java. Like we have got Android operating system. To each Android operating system they give some name, like Lollipop, Sandwich, and then Marshmallow, Kit Kat, Jelly Bean. Okay, for each operating system, for each Android operating system, a name is given to it after the name of the desert. Similarly to the Java, for each release they have given the name: Playground, Kestrel, Merlin, Tiger, Mustang, Dolphin. So up to Java 7, they have continued the practice of giving the names to the Java operating system, but they have dropped this practice from Java 8. We don't have any specific name for Java 8. And as we know that with each and every release, some new functionalities will be added, few APIs will be deprecated, performance of the JVM will be enhanced. So these are the operations they'll do with each and every release. So with each and every release, some libraries will be improved, and some additional libraries will be added. They will enhance the working performance of the JVM, loading and all. So with each and every release, these are the operations that will be done. We will not discuss all the features and all at this point of time. Later on, you can refer to this. Now, next starting with this JDK 8. JDK stands for Java Development Kit. JDK stands for Java Development Kit. So Java Development Kit means, okay, you've got all the tools to write your code, compile as well as execute. I repeat, JDK stands for Java Development Kit. And when you download this from the Oracle, it is available as a free download from the Oracle. And once you download the code and once the Java is installed on the operating system, it has got all the tools, as the name itself indicates, development kit. It has all the tools to compile as well as to execute. So you can, okay, in order to download, you can go to the Oracle, click over your downloads, and then, okay, you have Java downloads or Java SE. You can go over here, and then, okay, you have got download JDK server JRE and download JRE. So if you just want, if you are developing, as well as if you are developing the applications, then you require JDK. If you just want to run the applications, then you require JRE. So you can click onto this option JDK, and if you observe over here, you have got the different JDK available for the different operating system. So select your operating system. Based on that, okay, you can download. And let me just go back. So if you just want to download the JRE, okay, you have the JRE that is available for Linux, Mac, Solaris, and then the Windows. So the Java program what we are writing, it is available for the leading operating system. Okay, that is, okay, we have this operating system: Linux, Mac, Solaris, and then the Windows. So these are the leading operating systems for which JRE is available. Let's say you have got a Google operating. Let's say, okay, you have got a operating system that is released by Google. Let's say Chrome operating system. So if Chrome operating system has been released by the Google, then you need to write, or you need to have the JRE for the Chrome in order to execute the application. If you don't have, then you cannot execute. Clear with this? Any questions on this? You have got the GRE for specific operating system. So if you see this, if you have a look at this slide, so you have got GRE for Windows, you have got GRE for Linux, you have got GRE for Solaris. So that is if you want to execute the programs, then you should have the GRE installed. So once you download it, okay, you need to install, accept the license agreement, and then you can select and download it. Like at my end, it is already downloaded. So over here, okay, we have got JDK as well as GRE. If you download JDK, you'll get GRE as well. So these are all the tools. These are all in the bin folder. Okay, you will find all the tools that are required to develop as well as compile, profile, everything. All the tools you have. See, compiler, interpreter, debugger, applet viewer, and Java profile. So the tools what we will be using is Java. See, if you see, okay, this is your compiler, and okay, Java, this is used for executing the program. Jar signer, this is to create the jar files. This is your applet viewer to execute the applet. And then okay, we discussed about RMI, remote method invocation. You require this. But as of now, okay, we are not using RMI for distributed technology. There are other technologies that have come into picture that are more easier to code than writing the RMI. So clear on the tools?
Yes, yeah.
Okay. And then okay, now let us discuss on JVM. JVM stands for the Java Virtual Machine, and it is an abstract computing machine. It is responsible for the Java's cross-platform compatibility. Now, what do we mean by this is, so if you see, okay, you are just writing the compiler, you are just compiling the code, and the bytecode that is generated, you are capable of running it on the Microsoft, on Sun, on Solaris, on Linux, etc., etc., etc. So the reason we are able to run is because JVM, it is an abstract computing machine. Abstract in the sense, okay, you have got only the JVM, it has only stated the specification, that is you require so and so features to be implemented. Abstract in the sense, let's say they have given the rules. So you have got, let's say, okay, this is the rule 1. So they have just stated the specification, that is this all is required. Let's say rule 1, rule 2, or rule 3, or let's say feature 1, feature 2, and feature 3. This is the specification that has been laid. Now, next what we have is, now based on this specification, one is created by JVM, by Microsoft. They have implemented this specification. So JVM, it is an abstract computing machines, and it just lays the specification that if you require feature X, feature Y, and then feature Z. And each operating system, like based on the specification stated by the Sun, they have written the GRE for that. Based on that, okay, GRE has been written. So that is the reason if you see over here, you find so many GREs. JVM is there. So JVM is only an abstract computing machine. That is, it just has got the specifications laid out by the JVM. It does not have any implementation. That is how to compile, how to execute the code. It does not have any working code. It is just the specification. So using the specification as the base, JRE has been developed. JRE are written. Are we clear with this? Now what do we mean by this one is, now you have got JVM specification, rule 1, rule 2, rule 3, let's say, or feature 1, feature 2, feature 3, and this is implemented by Windows, and what you have is JRE for Windows. And the next, say you have got Chrome. So if Google is releasing the another operating system called Chrome, and so Google has to implement this, and then you can release it as a new JRE Chrome or Google. So this JRE, okay, if you are executing, if you have the Google operating system, let's say, if you're having the Google operating system, and if the Google has implemented the JVM specification, then it will release its own JRE, and you can make use of this JRE to execute the programs on the Google platform or onto the Google OS. Are we clear with this?
So the JVM will be the same for all the operating systems, only the JRE will be different, right?
Yes, correct. JVM will be same and JRE is different. That is the reason, okay, we are having JRE for each operating system. It is specific. Let's say, okay, you are releasing one more operating system by name Dolphin or some XYZ name, and then you don't have Dolphin JRE available, so it means that you cannot run the Java programs on Dolphin JRE. In that case, the Dolphin operating system, they should implement the Java specification. So they should implement Java specification, sorry, JVM specification by Dolphin for their operating system, and they can release this as JRE Dolphin. Clear on this? So JVM, as said, it is only an abstract computing machine, and implementation is provided by the JRE. So are we clear on this concept? That is the reason it says JVM, it is an abstract computing machine.
So we don't develop anything in JVM or
Hello, can you please repeat your question?
so we don't do any development in JVM, right? Or we need.
No, we don't do anything. That is the people, the Oracle people, they will write the engine code. We don't write the engine code. We are using the tools. JVM and JRE, it is provided by the Oracle. So we are making use of those tools in order to write the program. The engineers at the Oracle, they will write the code for implementation of JVM. We don't write, as you said, we don't write the code for the implementation of the JVM. So JVM, you can consider it as a tool for the developers to write and execute the applications, whereas the code for the implementation code for the JVM is written by the engineers at Oracle. So whoever is writing the implementation for JVM, they will do that. We don't do. We are making use of the tools. Like Microsoft, it provides .NET. Microsoft, it provides you with the .NET. So we are making use of the tools that is provided by the Microsoft, that is the .NET framework, and we are making use of that to build the applications. So .NET is provided by Microsoft and Java it is by Oracle. Are we clear on this?
Yes.
Yes.
So it is a tool. We don't write the code. We make use of the tool to develop the applications. Now, with this, okay, let us wind up the session for today and let us revise the concept what we have done. So do we have any doubts in the concept that have been discussed so far? Like we have discussed about the history of Java, can anyone please explain this? reiterate this? Okay, let me just do it. So history of Java we have discussed, and then we have discussed about the features of the Java. It is simple because as per the statistics, most of the bugs are because of the operator overloading and the multiple inheritance concept, and this has been eliminated. And Java, it supports object-oriented from the very beginning. It forces the programmer to write the programs in the object-oriented style. It is robust because of its garbage collection and the exception mechanism. And then it is architectural neutral. That is, Java is both compiled as well as interpreted. And it is powerful because it has got all these features. It is popular. It is distributed in nature. That is, you write once and you can run it on any operating system across the globe that is running on different hardware or platform connected via internet. Features of Java, multiple.
About the features of Java, you're mentioning about this digital signatures, right? Like serialization and digital signatures.
Now over here it supports digital signatures also. That is, if you want your program to be secure, then we have a tool that is called as JAR Signer, JARSIGNER. So you have got public key and then the private key certificates. So that will be introduced. So using that, okay, you can, for your code, verify the correctness of your code. You can sign that code with the help of the JAR Signer. Then you will have the public certificate as well as private certificates. And then, okay, you have got public key as well as private key.
It's a kind of a security application, something like that.
Yes, like any code, whatever you have developed, you can authenticate it. You can digitally sign that code.
Okay, okay.
You have got the JAR signer tool over here. So encryption and decryption mechanisms are built in. And then we discuss about multi-threading. Major editions, we have got 3 standard enterprise and the micro editions. Standard edition is for developing the desktop application, enterprise edition is for developing server-side application, and you have got micro edition for developing the application for the small devices that has got limited power and the computing capacity. And to execute the Java program, there we call it as JVM, and for the embedded it is KVM, and for the server side you have got containers. We will not dig into the containers as of now. And then we discuss about the various Java versions. Current version is Java 8, released in the year 2014. And we discuss about the Java development kit that comprises of all the tools that are required to develop, debug, as well as execute your applications. And then we discuss about JVM, which is an abstract computing machine. And your JRE, it is the implementation of JVM. So any doubts so far? Any questions?
No. No.
No, nothing from my side.
Oh, fine. So I request all the participants to type in their email address and then the phone number, because this contacts will be shared with Monica and she'll get in touch with you if required. So Monica has,
Sorry, come again.
so please request your, please share your phone number, the contact number as well as the email address, because this contacts Monica requires it. We have to share this with Monica and she will get in touch with you.
Yeah, that has already been shared.
Okay, fine. Those who have already shared, well and good. Those who haven't shared, okay, I request them to share their contact numbers and the email address that I will be sharing with Monica, and Monica will get in touch with you.
So you'll be sharing the slide, this PowerPoint through the email, that's what you're saying?
No, they have a procedure for sharing this PowerPoint.
Okay.
Link. So if Hema and we have Jay Ganesh and then Sarfaraz and Abhi, if you have already shared your contacts with Monica, well and good. Otherwise, can you please share it in the chat window?
I have already shared.
Okay, if you have,
With Monica, yeah.
okay. If you have already shared, well and good. If you haven't, please share it. And I'm sharing Monica's address. It is hr@mindsmapped.com. So if you have any queries, okay, regarding the course, okay, you can just drop a mail to Monica at hr@mindsnap.com.
We will resume the class on Monday. Or?
Yes, Monday. So please drop the mail, okay, because if in case if anything has to be communicated, then she'll be communicating from her end. I have shared her email address, hr@mindsmap.com. Please make a note of any of this email address. If you have any queries regarding the course and all, okay, you can just get in touch with her.
Okay.
Okay, thanks for your participation. With this, we'll wind up the session for today. See you on Monday.
Okay, thank you.
Thank you.
Okay, welcome.
Hi Atika.
Hi, Yasin. How are you?
I'm good. How are you?
I'm fine.
Are you typing something?
Yeah.
Actually, I can see your screen.
How come? Okay, fine. So how far you have completed your project?
I didn't find that slide in the online. I mean, I didn't see the video.
Okay, Sudarshan. So your email address ether underscore 448.
Mm-hmm. At yahoo.com. Do you have the project practical video?
That's yesterday's.
Yes.
Yeah, I have. I'll upload that. I did not upload that. It has to be uploaded.
Oh, okay. What time did you start this class today?
At 7.
Okay. 7 CST.
Like it was MST.
MST.
Anyway, this class will end within 2 to 3 days because we are almost at the end. Okay, then you can continue with that regular class.
Mm-hmm.
So
Yeah.
one we were using on this one, I guess, student management. So we have developed all this. No, it is student management. Okay. Now next, what you refer is okay. You need to develop the controller classes. So right click, new. Where is that? Java class. Let us keep it as student controller. So let us have a look what operations can be performed. Just give me a minute.
এখন কয়টা বাজে?
So now let us have a look at the operations that are performed by the, I think we wrote teacher controller. So open teacher panel. So what the teacher can do is activity diagram. Test screen you have, chosen test, new versions. So over here you have got the functionalities for the teacher controller. So starts an individual test. So you have to type the you have to do it. If this is a controller, then public void start individual test. So this is what you have. So over here you need to write the logic for starting the individual test. Then you have start a group task. Teacher is logged on into the application. Now over here the entry condition is teacher is logged in into the application. So over here can be done with the help of the aspect oriented programming. So log in, you can create it as an aspect. Log in, you can create it as an aspect that should be executed before any task that is performed by this teacher, by this actor. Clear with this?
Yes.
So this, okay, you have to create it as an application, login so aspect, and teacher chooses his test from home screen application goes. So at the end, okay, it should generate the ID. application presents the ID for the test, and then the test ID is shared. So when you are writing this code, group task. So it is generating an ID, string, start group task, and return the test code. So the test code, whatever is generated, it should be like you cannot share it with the individual students. What you can do is you can write the code to mail it. You can make use of the string mail API to mail it to the students. Mail the ID or link, whatever you are using. Clear with this, how to create?
Yes.
And then review the tests created by the other teachers. Now over here, if you see again, okay, teacher has logged in into the application. The code is being repeated. Now you can find that this login code is spread across the application. Then you can treat it as an aspect. So review the tests created by the grades. Fine. We can perform a peer review. Review the student result. Teacher has logged in into the application. So over here, these are the steps for reviewing. So this is how you will write or you will frame all the control classes. This is clear?
Yes.
So you know like how to write the what you say, how to connect to the database and all. So in the beginning, what you can do is just in order to test the application, you can create all your tables. You can design the database, that which we have already done. After you have designed the system, you can populate the rows with some data. So that is, you can create some test data so that okay, you can test your application accordingly when you are developing it. And then later on, you can provide an interface to the user to enter the details. So once you have created the database, after the database is created, please populate the database with the test data so that we can test the application with the database. Now similarly, what you have to do is, as you are creating the controller class for the student, so the other entities what we have is the student and then the admin and then the manager. These are the other three entities that we have in the application. So you need to create a controller for the admin that will perform all the operations related to the actor, and for the one for the admin, and similarly one for the senior manager. So total 4 controllers you require. Are we clear on this?
It means for access, permission access, for level of.
Yes, because if you see over here, you have got you have got 5 users. admin, senior manager, teacher, and then the student. And for each, you have to provide the specific functionality, a controller.
Okay.
So your domain classes are different, and then the controller class is different. Now, next thing what you have to keep in mind is when you are creating this domain classes, you're not going to write all the code here itself. You're not going to write your business logic in the controller itself. So for that, you need to create one more. com.example.service. And then, okay, you need to write the DAO classes. That is the code that will help you interact with the database. com.example.dao class, and within this, okay, you can write the code using the Hibernate to perform all the operations. So you have got let us write teacher DAO. Now, public void and create test. So over here you need to create one more utility class for connecting to the Hibernate. Session factory. Hibernate util.get session factory. And Hibernate session.open session. So okay, this is what you have created. Now create test. Okay, you have got this thing. So what are the classes we have for entity? Okay, okay. Test, we don't have any class. So actually you require one more class for creating the test. So because first you need to create the test and then you need to add the students to the test. That is the mouse cursor. Yeah. So you need to write one more entity class called test. Test. And then over here you can write private integer test ID, private date, test date, start time, and then you can specify the end time. What is the duration? Let us include this. Test ID, test. And then you can specify integer number of questions. Clear on this?
Yes.
Provide the getter in a second. So over here, this list object, you should get it from the form. And then you will be saying session dot save of. If everything is done successfully, then it should return the test ID. Now let us go back to this teacher controller. So show create test form. And then okay, you require one more method called public void process test creation form. Here with this you have got two things. One is like show create test form and the second one is process test form. Two things we have. So
Show is the paper when we write, or
no. Like let's say okay, when the faculty reflects on the show test, then you should get a screen with all these fields.
okay.
Test ID, test date, and then so over here what we will be doing is over here you will return model in view. So create test.html. Clear with this?
Yes.
Now over here you will create a test object and you will create one model and then view. Or else you can say over here model path. So model dot add clear with this?
Mm-hmm. Yeah.
We'll create one JSP over here. Hold on for a second, I need to plug the charger.
Mm-hmm.
So over here, point number 1, you need to include the tag dip directory, which we have already done previously, and then prefix, as equal to string, and URI as http www. So create a form that will match the form fields. Form action is equal to post, string nested path, path is equal to the name of the object, and then you have input type is equal to text, let me just copy from here. So nested path is test, post, where is the test class? Test date. And then next what you have? End time. So this is what we have, and this is date, and this is again date. Clear with this?
Yes.
I think this is start time is date time, I guess. Now you have to go to this dispatches servlet and register the controller. Bean ID is equal to teacher controller, and then class is com dot student dot controller dot. Property key is equal to create test.htm, and this request is going to your teacher controller. Okay, now let us just check it once. Let me comment all this.
Is it create test.htm or CREN?
What did we write? Oh, we require this context. Oh, let me just copy it. And go to index.jsp. Now let's create test. Not readable property session. So it means, okay, we did not provide setter or getter, I guess. Test. Okay, it is number questions. It is not number of questions. So you just copy this and then go to create test, and then it is number questions. Paste it. Execute it one more time. Clear with this? I think this is not giving you date and time. For time, let me just check it. Time element. Date time also you have, but okay, just check it again, but we have got date and time. HTML5 time. Okay, leave it, but you have the time element again where you can select it. I'm unable to figure out now as of now. So right click, run. So before we do that, okay, you've got show form. This is for get, and then this is for process. And method type, we need to change this to post. Create test, that is everything goes fine. As of now, you're not writing any code. And so test created, let us write. Go back to this teacher controller. And for this, the parameter what you require is iterate model attribute. And the parameter what you have is test t. You can retrieve all the values over here just with the help of system.out.println. Okay, now let us do it here. Then I'll show you how to put that into the database. Is it clear so far?
Yes.
So you have to do the same way for the rest of the forms. Windows, see the output. Let us go back to this controller. Request mapping, everything is correct.
Is createtest.htm or JSP?
This one?
No, createtest.jsp or HTML?
Correct, because the request is coming from create test.
But we created a createtest.jsp class, right?
Repeat.
We created a createtest.jsp.
Okay, no, that we are using to send a response to the client. But the request what we are getting is from this URL only. So you'll keep it same. It's not printing any error message as well. So teacher controller. Oh, sorry. Let me just change this. The request sent by the client was syntactically. Okay, fine. Because this date and time might not be matching. So we have to write again a lot of processing code to fix that. Let me just fix it. Because over here you have used date, so that is not matching. Oh, see, okay, fine.
It's start time and end time.
So let me switch to Chrome. I don't remember, but you get time field also in this. We'll do one thing because this date and that date it doesn't matches. Let me just change this to string. Because again you have to write the processing code for this. Time being, let me just change it to string. Test. Okay, I hope it matches now. Clear with this?
Yeah.
Now, what we have to do is over here, you will get all the form data over here. You get all the form data over here. Now, when you get that form data, you need to call this, where is that DAO, teacher DAO class. And from this, okay, you need to call this create test. Test created with ID is equal to whatever. Clear with this?
Yes.
And now, next what we have to do is, now next what we have to do, we have to integrate it with integrate Spring with Hibernate. I'll just show you, okay, what you have to do. Now, Over here, okay, session factory object will be managed by the container rather than you managing it. The session factory object will be managed by the container. So, not this one more you require. Over here, if you see, over here you have got like Hibernate, My Session Factory, org.springframework.hibernate 3.local session factory. So rather than you managing the session factory object, the session factory object is managed by the Spring Framework. Is this clear?
Yes.
So that is what we require. So now let us execute this one time. And let us check this. Username, password, and let me execute this one. Oh yeah, again you need to create one more file for the test because we did not create it. For test. You need to create a file for the test over here. Because we missed this class. property file we have. Let me just go to this and delete. Let me just keep with this. Rest all I'll remove it because we have to check whether any errors are there or not. Time being, I'll just comment this out. Let us execute this. We need to add the driver. Clear with this? Now let us see whether it has created in the database or not. Which database, what are we using? Hibernate. Go to the services, databases, Hibernate. See, it has created a table called test. Let us check whether the data is populated or not. Okay, the reason we are not getting this one is, I think, we did not save. Okay, we have to begin the session and then commit. Session dot get transaction dot begin.
The Hibernate is which database it follows?
Hibernate is?
Which database it save it?
No, Hibernate is a framework. I did not understand your question. Can you please elaborate?
Like MySQL or SQL Server, Oracle, which database it is same?
Oh, you can use any database, whichever you want. As of now, that
But,
you are connected to Derby, you can use any database. So you can Google, okay, a dialect supported by Hibernate. You will get a list of databases which the Hibernate provides the support. Hibernate dialect. So MySQL, SQL, Oracle, 11G, okay, this is what you have. Where are the dialects? See, these are the databases that are supported. You can use any of this. It provides the support for all this.
okay.
Click over here, create test. Submit query, hello world. Now let us check, go to the services. Clear with this?
Yes.
So this is how you have to do. So you have to write the form, you have to map it to a domain object and connect it with the controller, process the form, insert the data. That's it. So I've shown you one, okay, you can complete. First you should have the database design ready, and then okay, you can make
Mhm.
the combination of the Hibernate as well as Spring in order to perform this operation. So you don't have to write any SQL code over here. But if in case if the Hibernate does not supporting the extraction of data what you require, then in that case you can write the code in the native SQL because Hibernate supports that successfully. So are we clear on this?
Yes.
Okay. So with this we'll wind up the session for today. So I request you to complete the registration module and then the teacher module.
Okay. Can you please upload these two classes of practical projects
Okay, sure, I'll
so that
upload.
I can follow that?
Okay, I'll upload it.
Mhm. Okay. Thank you, Atika.
Okay, welcome
Have a
to.
nice weekend.
Bye bye.
We'll meet on Monday, right?
Yeah, sure.
Okay. Thanks. Bye.
Okay, bye bye.